In this lecture, let's look at the polar coordinates. Previously, what we were talking about was rectangular coordinates. For example, this point, the x coordinate is this long, and y coordinate is this long. Or you may say this long, okay? But anyway, this side, plus the two dotted side together looks like a rectangle. So then we call the coordinate xy is the rectangular coordinates. But we know that by Pythagorean theorem, one leg square, this side squared, plus another leg squared is the hypotenuse squared. So x squared is actually this side squared plus y squared is r squared. Okay, that's one thing we already know. Another thing we know is that y over hypotenuse is sine theta. Okay, we also know that x over r, the adjacent side of theta over r, is cosine theta. And then if both sides here multiplied by r, this r will be cancelled. So y actually equals r times theta. Here, and x do the same thing for the second equation. Then x is r times cosine theta. Okay, so basically xy can be determined by r and theta. So sometimes we then to express this point by r and theta. Okay, and then this coordinate will be called polar coordinates, because we know if we know the angle and we know how long this radius is, then we can exactly put the point right there. Okay, and we can also find out the rectangular coordinates by this relationship. Alright, now here is the example. Plot the point. You see r is 5 and theta is negative 210 degrees. We know first of all negative means clockwise. Okay, clockwise. So that means if the initial side was on the x-axis, then you rotate 210 degrees is going to be clockwise. Negative means clockwise. Counterclockwise is positive. Okay, so from here to here. We know negative 210 degrees is negative 180 degrees plus negative 30 degrees. So you rotate from this point to here, that's negative 180, and put another 30 degree, then it's going to be negative 210 degrees. And then 5 is the length, so you put it right there, so you know this will be the point. Okay, here is the important thing. The first coordinate is always the radius. The second one is always the angle. But when we locate the point, we always want to start with the second one. we do the angle first. Okay? Yeah, we locate where the angle is, and if it's positive, then we do it this way right here. Okay? Now, do we have other ways to express the same point? And here are the ways. You know, the first one is 150 degrees 5. Again, the straight angle is 180 degrees. This one was 30 degrees. So then the red one is 150 degrees. Positive. Okay? Counterclockwise. So they will have the same terminal. And then 5 is right there. So this is the one for the same point. Okay? So polar coordinates are not unique. It's not like the rectangular coordinates. They are unique. Okay? Alright. Now, how about the second one? Again, you want to start with negative 30 degrees. Negative 30 degrees is clockwise, so it's this far. Okay? But this time is not positive 5. If it were positive 5, it should be here. But this is negative 5, so it goes there. Negative 30 degrees is this one, terminal side. But here is negative, so you put to the opposite direction, like a vector. Okay? So, this is the second way. And this is the third way. You see, negative 390 degrees is negative 360 degrees plus negative 30 degrees. We know this is the one. Okay? So if you do negative 30 degrees, that's on this side. You can continue to rotate another 360 degrees in a negative direction. That will give you negative 390 degrees. So it's the same terminal side. But negative 5 is a negative vector, so it points to the opposite side. It goes there. Okay? So all those three polar coordinates actually describe the same point with the one right here. Okay? Now, that's the first example, is to locate the point and described by polar coordinates. Again, important thing, the first one is like a vector. The second one is like a degree, like an angle. Here it can be in degrees, it can be in radians. Okay? So, first one is a vector, the second one is an angle, but we always start with the angle. And then, depends on the sign of this vector, we'll locate the point. That's the first example. Now, let's look at the second example. The second example here is that given the rectangular coordinates, this is the one. Okay, we want to find two pairs of polar coordinates for the point, for this point, with theta in between 0 and 360 degrees. Well, 0 is included, 360 is not included. And plot the point. Okay? Here is that we want to find two pairs of polar coordinates. The previous example, we have found 4 pairs for the same point. Here we only need 2 pairs. Okay? Now, here is x, here is y. So we know r squared is x squared plus y squared. Is the first coordinate squared plus the second coordinate squared. The first one, radical 15 over 2 squared, is 15 over 4, plus y squared, radical 5 over 2 squared, is 5 over 4. 15 plus 5 is 20. Denominators are the same, you keep it. So 20 divided by 4 is 5. And then r, you choose the square root. In this way, r can be positive radical 5 and a negative radical 5. Alright. Now, then we need to find out theta. Okay? We know r, y over r is sine theta. Okay? So radical 5 over 2 is y. And then divided by r is radical 5. And then we then have a radical 5 over 2, change this division into multiplication by flipping numerator and denominators. Okay, so 1 goes up, radical 5 goes down. Cancel radical 5, then we have a 1 over 2. So if theta is 30 degrees, sine theta is 1/2, then theta is 30 degrees. That's the angle right here. And there is another one is 150 degrees, like the one previously we have seen. But anyway, there are two solutions. Now, again, this is the point. Okay? This is the point. The point is right here. Alright? Yeah. So, here we have y. Radical 5 over 2 is this part. And we have x is radical 15 over 2. So this is the point. And then right down here we have a radical 5. That's the vector or radians in this case. Radical 5, 30 degrees. So we know this one. There is another one. Okay? There is another one is what? You rotate the angle up to here. That's how many degrees? 210 degrees. Because rotate up to this far is 180. Then you do 30 degrees more. Then 180 plus 30 is 210 degrees right here. Okay? And then you put negative in front of the radians, it goes back. Okay? So in this case, besides this solution, we have another one, which is negative radical 5 and 210 degrees. 210 degrees. Okay? Yeah, so that's the two solutions. Right down here you can see that 30 degrees is in this range and 210 degrees is also in this range. So in this range, we can do is one is positive radical 5 for this one, another is negative radical 5 for this one. Okay? Yeah, please review this lecture. I'll see you next time.